Alright, so today I'm going to be talking about solving rational equations. And there's a couple of key things you need to know. Like, when you're solving a rational equation, you need to know what the domain of the equation is. Because when you get an answer, sometimes it's not going to work anyways. So, first we'll talk about domain. When you're solving an equation, you're not allowed to divide by zero. So, for example, if we were looking at this problem, we want to know the domain, but if we know that we can't divide by zero, we know there's a number that's not going to work for this. Our domain here. And it's written kind of formally, but really all you need to know is whatever number will make this zero. So what number plus 1 would be 0? That would be negative 1, right? So our domain, we could say, x is not equal to negative 1. So if we were, say, solving this equation here, we can use this as an example because it's got the same domain. If we got an answer of negative 1, we'd have to throw it away, and we'd get no solution. So here we have multiple pieces in our function. So we need to know what would make both of these pieces 0, then we can get our domain. And again, this is the important part right here. It's just right there. Very easy to see what your answer is, especially if you're given like a multiple choice test. So here our domain depends on two things, because two numbers will make the bottom 0 here. So this is very similar to the last one. We know x is not equal to, what number minus 1 would be 0? 1, right? Comma. Now this one's a little bit harder to tell, so what you could do is you could actually set it equal to 0 and solve the small equation there. So we would minus 1, we'd get 3x equals negative 1, and then we'd have to divide by 3 on both sides. So we'd find here that divide by 3, x equals negative 1/3, but we're going off of this, so we can put negative 1/3 in here. And that would be the domain of that one. This one is a little bit easier than that. Okay? So our domain here is based off the two bottoms. But some people, when they just see a random x, they don't know what to do with it. But if it's pretty much an x by itself, you're not allowed to plug in 0 because it'll make the bottom 0 here. So that's an answer right there. And then 4 minus what number would make the bottom 0 here? It's got to be a positive 4, right? So that would be the domain of this. So now we can apply that to solving actual equations. And there's a trick that I showed you in the picture earlier, which hopefully you paused and wrote down if you're studying this right now. The trick is to make all the bottoms the same. Then you can just throw away all the bottoms and you'll have an equation left to solve. Sometimes you're going to solve it traditionally, sometimes you'll solve it with factoring, it just depends on the problem, or the quadratic formula. So for number 1 here, all the bottoms are the same. They have a common denominator. So right away, we can take the equation and just throw out all the bottoms. So put a big line through it and solve this equation. So you need to get your x's together. So we can add this to this x over here. This would give us 2 equals 3x. Then divide by 3. And get our answer. Then just make sure you plug this back in, make sure it doesn't break your domain rule, which x would not allow to be negative 1. Well, it's not, so we have an answer. This one's a little bit more complicated because you need to know how to factor to be able to do this one. This was a couple sections ago. So our first step would be to factor this. And most of the time when they're making these problems, they make it a little bit easier by putting one of the factors into the other fractions you have, or both. So if we factored x squared minus 4, just remember it's a difference of squares. So that's going to be x plus 4, or x plus 2, x minus 2, equals, leave this one alone, can't do anything with it yet. Now we need a common denominator. So right now these are not the same, but we can make them the same easily just by multiplying this one by the piece that it doesn't have. So what does this one have that this one does not have? Well, it's got x plus 2. Now they are the same, but if you do it to the bottom, you got to do it to the top. So we can rewrite this. We have 8 over x plus 2, x minus 2, equals, we can distribute here, that's 2x plus 4 over x plus 2. Doesn't matter the order you write these either, x minus 2. They are the same, so use the trick, cancel them all out. And we solve the top. So we have 8 equals 2x plus 4. So, minus 4 to get our regular numbers together. We have 4 equals 2x. Then divide by 2. And get our answer of 2. But we got an answer of 2, we have to check it. So if we plug this back into, say, here, when we factored this, we got x plus 2, x minus 2, or even on this side. Right? It makes a 0 here. So therefore it's not an answer. We can't even use it. So the answer is actually no solution. Because our answer did not work. Okay, so moving on to the harder equations. When we're going to have to do factoring first. And really the factoring is just to check to see if the other bottoms don't multiply to equal that. Because if they don't, then it's going to be a little bit harder, but most of the time when they make these problems, it's not so bad. So, factoring this one is easy compared to this one. This one takes a lot more work. But all you need to know when it's just x squared is what multiplies to equal 5 that adds up to 6. So, you can start filling in your blanks. You have x first in both. What multiplies to equal 5 that adds up to 6? Like 5 and 1, right? So it's positive 5 and positive 1. Okay, and you can notice that it matches with these. So that's like a key thing, because that helps us get our common denominator. So we have 1 over x plus 5 minus 3 over x plus 1 equals negative 1 over x plus 5 x plus 1. The bottoms are not the same, so we still have to get it there. And to do that, all you have to do is kind of mix and match. So right now, this is only x plus 1, and this has both. So this needs an x plus 5. Now they are the same. And we do that with the first one as well. This is x plus 5, so it needs an x plus 1. If you do it to the bottom, you gotta do it to the top. Then we can rewrite, our new 3-term equation. So we have x plus 1, because when we distribute, we get the same thing, over x plus 1, x plus 5, minus 3 times x and 3 times 5, so that's 3x plus 15, over x plus 1, x plus 5, equals, we don't do anything to this one, so that's just negative 1. We'll leave it alone. Okay, so now that we have all the bottoms the same, we use our trick, cancel out all the bottoms. We just got to make sure in the end, neither of our answers are going to leave us with 0 on the bottom, because then we just get rid of it. Sometimes you get 0 answers, sometimes you get 1 or 2 or 3 answers. It depends on the problem. Okay? So here's something that gets people though, is this negative right here. When you rewrite this, you need to make sure to distribute that negative to both. So if this is negative, it'll become positive. If it's positive, it'll become negative. So we have our new equation, x plus 1 minus 3x minus 15 equals negative 1. And then solve. We can add like terms. X minus 3x is negative 2x. 1 minus 15 is negative 14. Then we just add 14 and divide by negative 2. So negative 2x equals 13, and then divide, we get our final answer. Make sure you're dividing by the negative as well. So x equals negative 13 over 2. And then you check, okay, it doesn't break any domain rules, so that is the answer, we're done. So here's another example, okay? But this one's a little harder because factoring this to verify that it's made up out of these two pieces is harder. So we're going to do that first. We have 2x squared minus 7x plus 3. And when we do this, we need two things that multiply to equal a times c, which is 6. A times c. That add up to negative 7. It's not too hard to figure out, right? Because if they multiply to equal 6, they have to be the same sign. That's a negative times a negative. So it's going to be negative 1 times negative 6, and negative 1 plus negative 6 makes that true. Okay, now we can factor it. So these two numbers that you find, replace the middle term. So we have 2x squared minus 1x, and you can write the 1 if you want, you don't have to, minus 6x plus 3. Then we factor by grouping. What do the first two terms have in common? Well, just x, that's it. And we're left with 2x minus 1, x is gone, minus, what do these two terms have in common? Well, 6 and 3 are divisible by 3, left with 2x minus 1. Notice the sign changed because we took out a negative here. Whatever sign is here drops in the middle of your two groups. And then we have our factored form. Everything on the inside goes in 1, and then everything on the outside goes in the other. So we can rewrite this. We have x over 2x minus 1 minus 7 over 2x minus 1 x minus 3 equals 1 over x minus 3. Now we need a common denominator, so we can combine these together. And use our trick to throw out all the bottoms to make this a lot easier. So we times this one by x minus 3. And this one by 2x minus 1. So we distribute. We have x times x, x times negative 3, minus 7 equals, distribute here, 1 times 2x, and 1 times negative 1. Notice I didn't write the bottoms because we don't need them anymore since they're all the same. We can cancel them all out. Sadly, we're going to have to factor again because this is x squared and you can't solve an equation with an x squared in it by normal means like we did here. So, we get everything to one side. We need equals 0, so we're going to minus 2x, add 1, add 1. So we get x squared minus 5x minus 6 equals 0. Hopefully that's factorable. If it's not, we have to use the quadratic formula, which we haven't learned yet in class. So, well, I made it so that it's factorable. Alright, so we need two things that multiply to equal negative 6. We don't have to use the long way like we did in that one because there's no number in front. So what multiplies to equal negative 6 that adds up to negative 5? And we'll have our answer right away. X is first because x times x gives us that x squared. So what times what is negative 6 that adds up to negative 5? Negative 6 and positive 1, right? Then we get our two answers. You just have to make sure to check your two answers. So what number minus 6 is going to give us 0? Well, x equals 6 would do that. There's 1. What number plus 1 would give us 0? Well, that's negative 1. So just make sure that these don't affect our originals. 2x minus 1, x minus 3, well, they don't, so we're done. And that's the answer. We get two answers here. So that's it for the video today.